Hello class, myself Supriya Gadke. Today I am discuss Unit 5 Vector Integral Calculus and Applications. So I request to all of you to subscribe the channel to get the all videos made by me for you on all the units. So from the Unit 5 we first learn the Green's lemma. Green's lemma says that consider the closed curve C enclosing an area A. Let U, V and their first partial derivatives be continuous and single valued over the region bounded by curve C. Then integration over C U dx plus V dy is equal to double integration over area A delta V by delta x minus delta U by delta y dx dy. So this is our Green's lemma. I again state that integration U dx plus V dy is equal to double integration over A delta V by delta x minus delta U by delta y dx dy. So we solve some examples by using Green's lemma. First example is using Green's lemma evaluate integration over C x cube plus 2y square dx plus 3xy plus 4x square dy along the closed curve formed by x equal to 0, x equal to 1, y equal to 0, y equal to 2. So by Green's lemma we have integration over C U dx plus V dy is equal to double integration over area R delta V by delta x minus delta U by delta y dx dy. That is equal to double integration over R delta V by delta x is here V is 3xy plus 4x square. Taking derivative with respect to x, so with respect to x derivative of 3xy is 3y and with respect to x derivative of 4x square is 8x. So 3y plus 8x minus delta U by delta x. So U is 3x cube plus 2y square. So derivative with respect to y is of x cube is 0 and 2y square is 4y. So minus 4y. So double integration over R, that is 8x as it is, 3y minus 4y is minus y. So 8x minus y dx dy. Putting the range, x varies from 0 to 1, y varies from 0 to 2, 8x minus y dx dy. So y taking the derivative integration with respect to y, that is 8xy minus y square by 2, taking limit 0 to 2 into dx. First we integrate with respect to y. So put the limit 2 here, we get 16x minus 4 by 2, that is y square, that is 2 square is 4 and here y is 2. So 2 into 8 is 16, x as it is, 16x minus 4 by 2 dx. Again take integration of these terms, so 16x integration is 16x square by 2 minus 4x by 2, that is 16x square by 2 minus 4x by 2. So 2 and 4 get cancelled, so remains only minus 2x. So put limit of x 0 to 1. So that is equal to 16 by 2 minus 2. After solving we get 8 minus 2, that is equal to 6. So our final answer integration over C x cube minus 2y square dx plus 3xy plus 4x square dy is equal to 6. Now second example is using Green's lemma evaluate integration over C f bar dr bar, where f bar is equal to sin z I bar plus cos x j bar plus sin y k bar, and C is the boundary of rectangle 0 less equal to x less equal to pi, 0 less equal to y less equal to 1 and z equal to 3. So integration over C f bar dr bar is equal to integration over C sin z into I bar cos x into j bar sin y into k bar, and dr bar is dx I bar plus dy j bar plus dz k bar. So taking dot product of these two, we get sin z dx plus cos x dy plus sin y dz. But as z is equal to 3, so dz equal to 0. Z is 3 is given. So derivative of z is 0. So our integral becomes integration of c sin z dx plus cos x dy. Comparing with integration over c u dx plus v dy, we get u is equal to sin z, v is equal to cos x. So by Green's lemma, we have integration over c u dx plus v dy is equal to double integration over y, double integration over r, dv by dx minus du by dy dx dy. So that is equal to, our value of v is cos x. So dabba by dabba x with of cos x minus dabba by dabba y of u. U is sin z dx dy. Double integration over y. Derivative of cos x is minus sin x. And derivative of z with respect to y is 0. So that is 0 dx dy as it is. Now range of integration is y running from 0 to 1 and x is running from 0 to pi minus sin x dx dy. So first integrate with respect to x, we get this minus sign as it is. Integration of sin x is minus cos x 0 to pi dy. So minus minus becomes plus 0 to pi dy integration over 0 to 1, that is equal to integration 0 to 1. So putting the limit cos pi minus cos 0 dy. So 0 to 1 minus 1 minus 1, cos pi is minus 1, this minus sign as it is, and cos 0 is 1. So that value becomes minus 2. So integration 0 to 1 minus 2 dy, that is equal to minus 2 times 0 to 1 dy is equal to minus 2 times y 0 to 1. So putting the upper and lower limit, we get the value minus 2. That is our final answer. Third one problem is evaluate integration over c f bar dot dr bar for the field f bar is equal to x square I bar plus xyz bar over the region R enclosed by y is equal to x square and the line y is equal to x using Green's theorem. So by Green's theorem, we have integration over cu dx plus v dy is equal to double integration over r dabba v by dabba x minus dabba u by dabba y dx dy. So integration over c x square I plus xyz bar into dx I bar plus dyz bar plus dz k bar, that is given integration over c f bar dr bar. So I can write here f bar and this is dr bar. So taking dot product, we get x square dx plus xy dy, and that is equal to double integration dabba v by dabba x minus dabba u by dabba y dx dy. So phi is xy and u is x square. So derivative with respect to x of v, that is derivative of xy with respect to x is only y minus derivative of u with respect to y. So u is x square with respect to y, derivative is 0. So double integration over y dx dy. So that is equal to double integration over y dx dy. Now we have to put the limit. Here, if the read question carefully, here over the region R enclosed by y is equal to x square. So y is equal to x square is this graph. Y is equal to x square and y is equal to x. And the line y is equal to x. Here R enclosed by R is equal to x square and line y is equal to x. So line y is equal to x is this line. This line y is equal to x, and this is graph of y is equal to x square. So x running from 0 to 1, because here 0 to 1 up to 0 to 1 x runs, and for the limit of y, lower limit is running from this boundary. So this boundary is y is equal to x square. So lower limit is y is equal to x square, and upper limit varying from this line. This line is y is equal to x. So y is equal to x is upper limit here. So first we put the derivative. First we integrate y with respect to y. So we get y square by 2, and upper and lower limit are x square and x dx. So integration